Hey guys, today we'll be working on another C programming tutorial. We'll be going over the realloc function in C, which can reallocate memory. You can increase memory, decrease the size of the memory. You can change the block. So if you want to increase the elements and there's not enough space, it'll allocate a new block with a new pointer address. If you can modify the same block, then it'll keep the same block. So just remember, if there's not enough space, it'll return a pointer to a new address. So we'll just start with the code. It's pretty much the same as the other code, so for malloc and calloc, but I'm just going to write it again, I guess. So we'll just have hashtag include stdio.h, then hashtag include. You're going to need stdlib.h. We'll have an int main here. Also, we want an int n, I, and pointer ptr. We'll say we're going to print f. So we'll say enter total number of vowels. So we'll call this the scanf function. We'll pass in our format modifier. And we'll pass it to the address of n. Then here we'll call our pointer. We'll say it points to an int casted to malloc, which is the memory allocation function. We already went over this in the previous video. If you haven't seen it, it's in this playlist just before this video, a couple videos before. So here we'll say, so remember malloc takes a size. So we'll say we want n times, it only allocates one block, versus calloc allocates multiple blocks. So we'll call the size of function, which we'll say that the size of is the size of an int. So size of just checks the size of the variable, like the primitive type. So an int is 4 bytes, so it's going to say, okay, we want n times 4 bytes. So it's going to allocate that much space. So ptr points to int pointer casted to malloc, passing in size of an int. Then here we'll say, we'll call the printf function again and say enter the values. So we'll enter some values to store in that memory address. So I'll have a for loop here for I is equal to 0, I is less than n, I plus plus. We'll call the scanf function, pass in %d, and then we'll say we want to enter the values at the address ptr plus I, because remember, a pointer is like an array, so if we just call ptr, it's going to start at index 0. After that, we'll call the printf function. We'll say enter updated size of n. So say scanf, then we'll call %d, and we'll change the address of n. So then here we'll So we're saying enter the updated size of n. So we're going to change n. For example, we'll increase it from 3 to 4. And then we'll say we're going to have to create a new pointer. I believe you might be able to use the same one. You can try it both ways. So we'll just have int ptr so int ptr1, so int pointer int ptr1 points to casted into realloc, which takes the old pointer. Actually, okay, I think you do need a new pointer because it takes the old pointer. So we'll have ptr comma then n times size of, and then pass an int again. So here we'll just print the addresses out. Whoops. Put a new line here. So we'll say previous address %d new address %d, then we'll pass in ptr and then ptr1. I think address might work too. If we just tag on like the address, the ampersand, we could use the ampersand as well. So we have printf previous address %d comma new address %d, close end the string, then comma. We're passing in ptr for the first %d and then ptr1 for the second %d. And we have we'll have a printf again. So printf, the entered values are. New line. So the entered values are new line, and then we'll iterate through the loop again. For I is equal to 0, I is less than n. Sorry, we'll iterate through the pointer, which is basically an array. Because remember, memory is like an array of bytes. So we're really just referencing an array. So we have printf. Actually, sorry. So we have I is less than n I plus plus. I plus plus. Excuse me. So for I is equal to 0, I is less than n I plus plus. And we'll have printf. And we'll have %d with a tab, escape sequence, and we'll have comma, pointer value, then in brackets ptr 1 plus I. So that's going to start at index 0 and then address index 0 and then add 1. Add I each time to shift through the addresses in order, basically. Because every time we increment by 1, so it'll get each address. So for I is equal to 0, I is less than n, I plus plus. Printf %d tab, comma, pointer value in brackets ptr1 plus I. And we'll call free at the end to free r. ptr1. I think we could also free ptr as well. ptr1. And we'll call free ptr just in case that's just hanging around still. So we're freeing the memory ptr1 and freeing the memory ptr, right? To save that. So I hit Control S to save it. That should be all. Sorry, just hit the mic by accident. Okay, so we have that's about it. So then we will add a breakpoint here. That one probably won't hit, so here. I'll just go for here just in case. So we'll save that, and then I'll click the debugger. So these were declared. Sorry, yeah, so N, I, and start PTR, they're declared, currently storing garbage values. Or zeros. So we'll go print, so enter total number of vowels. That's going to come up on my output. So we're going to scan F, we're going to enter a value for N. I'll enter like 3, I'll hit enter. So it's going to allocate memory. So in this case, since it's malloc, it's going to be one single block, compared to calloc, which is multiple blocks, and which initializes them to 0. Malloc initializes them to garbage values, the block of memory initially, before you store the values in it. So step over and then printf, enter the vowels, so we'll enter the values. I'll step in and then step over, because if you step into scanf and printf, it might bring you to a built-in function. So I'll step in, I stepped over, not in. So I'll enter the value, I'll enter 1000. I'll step in, step over 1001. I'll step in and then over 1002. By stepping in and stepping over, I mean these buttons here in the debugger console or the panel. You can have control over the debugger. So again, I'll step in, which is the loop will skip because I is 3. So 3 is not less than 3, so this was false. It skipped the whole block from this block to here. Ended here, now we're here. So enter updated size of n. I'll step over. I'll step over again. Sorry, I just the second time I clicked another window by accident, the video stopped. So we were just at printf, enter updated size of n. That was done. Then now I've stepped over scanf, so it's waiting for a value to change n. So I'll enter 4. I'll hit enter. Then it's gonna reallocate the PTR to the new PTR with the new size. So it's probably gonna allocate a new block. So it's taking a new pointer. It's gonna say, okay, we want a new pointer. We want to point it to the reallocation function, cast it to an int pointer, and pass in the old pointer address and the new size, which was n, which is the new size we changed it. Right? So it's just, you could probably allocate a new block with the same amount of bytes, same thing. If you allocate less, you'll just be warned that you'll lose your probably lose your memory from certain indexes. So if we go from 4 to 2, we'll probably lose two indexes of memory. Okay, so we'll skip to the next line. Previous address and new address. So I'll tell you what that is. So we have sometimes this can glitch a little bit. We have previous address -17283098808. So it looks like it's the same number twice. The new address is -17283098808. So sometimes it can glitch out. Unless I messed up. I don't think I did PTR. PTR and PTR1. So I think it's just a glitch. So just don't worry about that. And the entered values are, we'll just print out the values. Oh, I stepped in, great. Step out. Step in. So that's what happens when you step into a built-in function. Sometimes it'll take you to like some random code, and you could get there stuck for a long time. So if you do try to click the step out button in Java, if you step out, it still takes you through the code. So sometimes it could glitch out both ways. So here we'll print out the values. It's just going to print out the pointer value at the address PTR1. When you call just a pointer like that, remember, like an array, a pointer array, it's going to start at that first index 0. Excuse me. Then it's going to add I to it each time. So the first time it's going to go, we want the value of the address PTR1 plus I, which is 0. So it's just going to give us the value at PTR1, because if we add 0 to PTR1, it's still going to be the same thing. So it should print out 1000, which it did. Step in, step over, then this time it's going to add the value PTR1. So it's going to print out the value of PTR1 plus 1. So it's going to shift over an index. So it's just going to continue to do that till there's no more values. So the last value, we didn't add a value to it. But if we did, it would have been it would have had another value in there instead of it printed out an address. Or it's actually no, it printed out a garbage value. So then we freed the pointer 1 and freed the pointer 2, and that was it. So changing this whole thing probably will take a long time to go through it again. What you can do is you can probably you can somehow iterate to that last index, PTR plus, because when n changes, so you can go PTR plus 3 or 4, 3 or 4. So on that last index, you can add a value somehow if you want, and then you can check your output and see how the value was added. So yeah, that's gonna conclude it. Hopefully that helps you with realloc, malloc, calloc, functions that are hard to understand unless you, and free. So malloc, calloc, realloc, and free. So the functions are hard to understand just by reading the docs online. They don't really make sense. Like, it didn't explain everything properly. So hopefully this video helps. I know when I learned understanding I was able to understand it more after I kind of looked for some more information. So hopefully this will point you guys in the right direction. It's pretty much just creating blocks of memory, allocating them, either a single block, multiple blocks. Then you can modify them, modify new blocks, get a new pointer, because remember all these functions, malloc, calloc, and realloc, they all return a pointer, or null if the pointer is null, if it's a null pointer, We didn't handle it, and I think in the first video, malloc, we did handle it. So that shows you how to handle the null pointer error. And yeah, so, and then you remember to free up the space, memory space, when you're done with the function or the variable. When you're done with the pointer location completely, free it to save space in the system. That way you're not wasting space and you won't get a severe error later on, fatal error, memory error or something. So just make sure you free up the variables and the pointers when you're finished with them to save space, so you can use that space for more memory allocation later on, and that's it. So I think there'll be one more video in the series. It'll be just a quick thing on macros, and then we'll have 2 project videos. Okay, so 3 videos, and that'll be it. So that'll end the series, and then we'll go on to Python and C#. Actually, I still owe you guys some Android videos, so I'll try to get those out too. So I'll probably do those at the same time. I'll start getting the Android videos out, and then we'll be jumping into Python and C#. So we'll be using these concepts continued in C#, and then after that we'll be doing JavaScript, HTML, CSS. Oh yeah, so Android's also XML, so it's XML and Java or Kotlin. I use Java. We may do Kotlin in the future. It's pretty similar. You can change the codes to Kotlin pretty easy. I think there's like auto formatting to change the codes. And then we'll also do C++. So pretty much, if you guys are interested in more programming videos, you can subscribe to the channel and like the video if you want. If you're interested in the new series, the new series that will be coming out. The new series that's going to be coming out. Is that a word? I think it is. So yeah, so there'll be more series coming out. So yeah, Android, XML. That'll be a quick 5 video series, but those are long videos, long apps. We'll do 5 apps with all the pretty much basic concepts. It's basically everything except for like location. So we'll do the location stuff later on. So yeah, so it'll give you guys a good foundation of Android. Then after that we'll do an XML, which is important. You can use that XML in a lot of things, other apps, other languages. So then we'll do Python, C#, JavaScript, HTML, CSS. So JavaScript, HTML, CSS, that's going to be one series. Android and XML, that'll be one series, and Python will be Python and C#. Oh no, so yeah, Python will be its own series, C# will be its own series, but I'll be doing the videos together because when I took the class, we learned them together. So yeah, so there you go. That'll pretty much be the next year or so. So yeah. So if you guys like the video, and I'll see you guys next time. Thanks for watching.